This time I got a Panasonic DMRES20 DVD Recorder. This one here is dead. Well, not dead, it just won't turn on. And we're going to take a look and see if we can figure out what's wrong with this one and see if we can make it work. This time I've got a Panasonic DVD Recorder in for repair. I don't know whether we're going to have any luck with this one or not. It kind of sounds like it could be a logic board problem, but we'll see. I'm going to plug it in. Apparently the display does weird things and it won't fire up, so we'll see what's happening with this one. So power. The display just displays 00000, like it's booting up. But apparently that's all it does. It doesn't ever boot up. So I'm thinking possibly bad capacitors on it. In fact, I can see right now there are at least a couple that aren't any good. Like these ones here, the tops are popped on them. So we'll start by, we'll just change out a couple of these caps here and see if that'll get this one operational. It'd be great if it could get this one running. But we'll try that and see what happens. First things first, I have to get the main board out, which is going to be a challenge in itself. Guess the front panel has to come off first. That should pop off relatively easy, I would think. Get the front panel off, get that out of the way. A couple plugs down here. All these screws obviously are going to have to come out to open up the board. I see at least two caps here that are definitely bad. These two, I mean, this one's already leaking, that one's kind of popped a bit. There may be others, but we'll start with those. I'm sure there's probably some on this one too. I think this is loaded with surface mounted caps if I'm not mistaken, and they did tend to go bad on some of these machines. But let's hope that they are not. I'll unplug the drive, remove this board, the logic board. Technically, this is the MPEG board that does the MPEG compression and encoding and decoding.
Got surface mounted caps on it, and we know how reliable they have been over the years. But we'll start out with the power supply caps over here and see if that'll make this thing operational. Got to remove a whole bunch of stuff off here to take this board out. Right, I've removed the screws on the back. The tuner should unplug from here. Maybe it should just pop out. Maybe it's going to come out with the entire board. We'll remove the screws. Let's secure the board down and see if we can lift the entire board out with the tuner. I'll unplug the fan and everything that may hit it. To say there's a lot of stuff that's got to come out on this that's for the firewire input, just to remove the board. Undo this clip here and undo this plug with the drive and a couple more screws, and then maybe the board will lift out. Okay, now that the back is off, The screw right there. I think that's what's holding it. Alright, now the board will lift out. But here's the caps here I'm going to change out for starters. There's 2 of them here. We'll check the ESR on the others. But we'll start by replacing these 2 and see whether that will get this unit to boot up. Yeah, that's one of the ones that I suspect is bad. Well, I know it's bad because I can see it, see the top popping up. That one there's okay. That one's okay, and this other one over here, if I can find it, should be bad. That one, where is it? That one? Yeah, that one's bad. We know that. And this one over here. That one looks okay. I'm just doing a quick check in circuit. I think it's probably just those 2 that are bad. Yeah, 0.04. 0.0, you know. Yeah, I think these ones are okay. I think it's probably just those 2 that are visibly blown. I think just those 2 are those were the 2 that were measuring bad. The others, the ESR is testing fine. So we'll change these 2 that are definitely bad, and then try it and see if it will fire up. And fingers crossed, it's going to boot up and it's going to work. We'll start out with this one here that we know for sure is shot. It's C1400 for those keeping track at home, and it is a 470 microfarad at 16 volts, and it is an ELNA cap, so let's find a 470 at 16 volts. I'll replace it with a 470 at 25 volts. Little extra headroom here, can't hurt. That's usually why these failed, is because they were running them too close to their rated voltage. It's probably on a 12 volt rail and they put a 16 volt cap in because it saves them a penny. And the other one was this other one over here that measured a little bit high. And that was, I think it was this one here. Was it not? C1270. I think it's this one, C1270. Yeah, that's the one. That's the one. It's just it's tight to the board. Gotta work it out a bit here. This one is also an ELNA, and it's a 1000 again at 16 volts. Replace that with a 25 volter. I'm sure it will. We'll replace it with what I've got that's closest to it. How's that sound? This one's a 1000 at 35. Well, that should be fine. As long as it'll fit in here without touching anything, I think we're okay. Yeah, it should be okay there.
Now there may be more wrong with this than just these caps, but we got to start somewhere. So I may be wasting my time with this. It may be beyond repair. We don't know at this point whether there's any other damage that's hidden that we haven't spotted, or whether there's any other caps that are bad on that other logic board, or whether the logic board was damaged. We won't know any of that stuff until I actually get the board back installed and get everything plugged in. The downside to working on some of these devices is that when you have to do such an extensive disassembly just to get to anything to work on it, they're kind of a pain in the butt, because you got to reattach everything before you can test anything. There's a plug at the front and a plug at the side here, or a plug at the back and a plug at the side. Tune for maximum smoke. Making sure nothing's touching. We have power. And I got the O's going across the front here, which is customary when it's booting up. We'll see whether they will let me turn it on. This is generally indicating it's initializing. So that board might be bad. Hello, it says. Is it going to do more than that? That's the question. Open close button is over here somewhere. I don't know if it's going to do any more. It might be other problems still with it. I would think the problem is probably on the logic board. So we're going to pull the logic board again and just measure some of those surface mounted caps on there and just see if there's any that are really bad. I'm sure they probably all are, but more than likely the fault is on here because it's not initializing. When the unit first powers up, it goes through a power on self-test initializing, where it tests everything and it'll test the drive and everything, and well, it's not getting to that state. So very likely something is dead on this board. It could even be the processor for that matter, but we'll check these caps out because this is what controls the drive directly. So we'll check these for ESR, just see how bad they are. There's not that many, and it may only be one or two of them that are bad, that are causing it to not boot up. Although the last one of these I had, that was the board itself was no good. But let's just check the ESR here and see how our ESR is and how bad it is. .5. .1. Or was it 0.1? Yeah, 0.1. They're 100 microfarad at 6 volts, so 100 at 6 volts, well, 100 at 10 volts would be 1.2, so anything below 1 ohm should be fine. That one's okay. These two are okay. What about this next one? This next one's a 47 at 6 volts, so according to my chart, that should be better than 2 ohms, lower than 2 ohms, and this one looks to be open. So maybe this was the one that's causing it. Oh, wait a minute. It's just my probe isn't making a good connection. Try that again. 97. That one's got to be open. Okay, let's get to the next one over here. That one looks okay. 0.4, that one looks okay. That one's not bad. That one's not bad.
Looks like that one there is bad there. We'll change that one out. And that one also could be bad. What is this one? 10 at 16. Well, yeah, it's a little high. This one here is 47 at 6. That's a little bit high too. Not as bad as the other one. And this one here is 1.3. We'll try this one first. I'm just going to do the one and see if it boots up. This is a 47, so let's see what I can find in 47. Actually, you know what? I guess my probe wasn't making a good connection because I just checked this again and it was like 2.8. Where was it here? Yeah, see, that was not bad. Just my probe wasn't making a good connection. 2.2. So that one doesn't appear to be that bad. Why my probe sometimes not making a connection there. I don't think it's bad, but what the hell. I'll change it out. The other one I was concerned with was one of these other ones over here. I'm just going to check that again. We'll change the one that was high. One of these ones measured a little high. We'll change those ones out. And see whether that does anything. That was 1.8. That was okay. This one here was measuring at 7.1. That one might be a little bit on the high side. 13. That one's definitely high. And this one here is 1.8. 1.8. Yeah, this 10 over here at 16 volts is 13. And 8 would be considered to be kind of marginal. So let's just change out this little 10 over here. And then we'll try it. I'm not holding my breath, but it's worth a try, right? Worth a try to see whether it will make any changes to it. So I'll plug the unit in again. It's still doing the 00000, which is not good. It should be in a initializing state, and should. Mine says please wait. Or wait on the display. I think it says wait for maybe 10 seconds and then it fires up. But this is not passing initialization. Just going to see if there's any voltages that appear to be missing. I don't know what they're supposed to be, but I'm going to look for the usual suspects: 5 volts, 12 volts, 3 volts, whatever, right? So we'll just start checking some voltages here and see what we've got. We've got nothing there. 5 volts there, so the 5 volt supply is okay. 2 volts, 4.7, 0, 5. So we are 5 volt supplies there. It should be probably a 12 volt rail. And here somewhere too, these are 5 volt rails. Don't know what any of these other ones are supposed to be for 5 volts. 0, 5, or 4 point something. I'm sure there'll be a 12 volt rail in here somewhere. There, 13.2. So there's our 12 volt rail, minus 12. I think our power supply is probably working. And it's 13.2, so it's it's something else that's gone bad on this. I mean, those two caps definitely were bad. That one and this one were definitely popped. The others are testing okay. So it's likely something on here. And this processor is getting warm too. The drive's not opening. It's all being commanded through here. I think this board is probably shot on this unit, and that's why it's not working. It may have been damaged when the caps went bad and there was excessive ripple getting to it, but all the caps on this other board test good. I changed out a few of them because, you know, they're just a little bit questionable as far as the ESR goes, but the other ones are all well within spec. So I think this is probably going to be a write-off, this one. These don't have a lot of value to them. I mean, it's nice to have it because it supports DVD RAM. I've got one that doesn't work. I've got one that's got a dead pickup. Unfortunately, it's a different drive than this one. But I mean, it even could be the disk. It could be the drive, for that matter, right? It could be the drive that's not initializing. That's always a possibility. Is that the when you power it up, it's expecting the drive to communicate back with the board, and it's not. Waste a little more time before condemning. Get a few more minutes of video time to bore you guys. You're leaving in droves. Now what's remaining here? Oh yeah, the power cord. That should be long enough to pop this up. See, there's ICs and stuff on here as well, right? So it could be something on the drive that's bad. And yeah, it could be anything. It could be the drive itself or the control. This is the MPEG board that does the compression. But basically, what happens when these things power up is they go through a power on self-test, where everything communicates with each other, and if something is not communicating, then they just won't go past the initial startup. They're dead. I wonder if the drive's getting power. Certainly check to see whether there's power on the 12 and 5 volt rails. The drive, I powered up, I should get power on here. I think these are the ones. We'll see if the drive's getting power. Something interesting I note on here is that when I power it up, my 5 volt line comes up on the drive. If you see the meter, and it's going to drop to nothing. So I think probably what's happening is see, it goes down to nothing. The 12 volt rail is there. Where did it go off to? Yeah, it's still there. That one's got nothing on it. That's another red wire. I would expect it would be 12 volts, but it's not having any power on it. But could be missing one of the 12 volt supplies, I guess. I'll just pull this board again and take a look, because I see two red wires here, and I would expect that they're both 12 volts. I only see power on one. I don't see power on the other. It's very possible that it's doing initialization for the drive, and the drive itself is not responding, and it shuts down. Maybe that's the problem. It might be a bad drive too. Or we'll just take another look at the bottom of the board here. Waste some more time. See if I can get lucky on this one. Not holding my breath. Let's say I've got one that's dead, but the one I've got is the laser is shot on it. It tries to read, but it never reads the disc. You see the laser come on, and it's very, very weak, like very dim, red, right? Very dim laser, and it doesn't. It never reads the disc. So well, the two red are connected together on this side, but I was only getting power. I was only getting 12 volts on one of them, although I don't know if the other one, whether it's connected at the other end. It might not be, but I'm just going to resolder. Okay, check this out. Okay, here's the connector, the power connector.
The 5-volt line, if I measure from here, I get continuity. Where are we here? The next one, ground. The next one over is a positive 12. No continuity. And this one here, I wonder if it's on the other side of this board here. Let's just check that connector on that other side of the board and see whether there's a connection that is bad there. Because when I tested it, I had 5 volts, 0, 0, and plus 12. And both of these two are connected together over here. They're right here, they're bridged together. So I should have 12 volts on both of those, and I only had 12 on one. And when I test the plug here, this one is not going through to the pin. I wonder if there's a connection that has failed on the other side of that board. And I have to carefully open this up because I don't want to disconnect anything. I don't want to disconnect the laser because I don't want to subject it to any transitions, static transitions, right? Transients. Do the little motor here and slip the board over and take a look at that connection on the other side here. It was this one here. I'm just going to redo it. Redo that connection right there. And we'll then check it and see if I've got the voltage back. Get my extra set of eyes on here so I can see what I'm doing. They might not be connected to the other side here, right? They may only be connected on the one side and this other one just happens to go through and one doesn't. That might be what I'm reading. Just before putting the set back together, I figured I'd go over it one last time just to double check everything, make sure I didn't miss anything, check the IC protectors because there's a bunch of little fuses on here, right? There's a bunch of little fuses on the board. So I went back to check them all. Of course, they're all good. They're just these tiny little green like little chips here, right? They're little fuses. There's one there, and they're all pointed out by these little arrows here, right? They're all testing good. And while I was inspecting the board closely, I found what I think the real problem is on this one. Check out this IC, it's got a hole burned in it. This IC right here. That IC is shot, and that's connected directly to one of the caps that the top is blown off on. But it sure looks like that IC has a hole in it. And if I, yeah, this IC here, if we look at it closely, it's got a hole right there. You can see it. Probably see the black soot that's coming out of it where it's burned. But that IC there looks like it's burnt right up. Can't even see the number of it. But there's definitely a hole that's burned into that IC. That's IC 1401. It's connected directly to, this is one of the capacitors that went bad, right? Right to that lead there. So more than likely what happened is when the ripple got high because the cap went open, this IC failed and popped. So that's where we stand. I can't even tell you what number it is because it's burned quite badly. Let's see if I can see it here, but anyway, I'm pretty sure that's where our fault is. And I have no idea what that part is or whether it's even available. But it's IC 1401. So this one will be going back together, and I'll let the owner of it know that there's an IC that is bad on here. And do some research and see if I can find out what IC 1401 is.
And I think it's probably pretty unlikely that this part is not available, because this unit here is from 2005. So, you know, it's what, 15, 18 years old. So I doubt very much whether we're going to be able to get parts for it, but after finding that, I'm pretty certain that that is where our fault is. So I'm just going to throw this unit back together, and we'll leave it at that. Thanks for watching.